Okay, babies, welcome back to Discrete Math. This is going to be the second half of the semester, which I enjoy very much. There was a huge hack on Twitch, so please let me know if you see and hear everything okay. They reset the stream keys, and I am uncertain if this is all okay. Someone's DMing me on Discord, but I really can't look at those while we are in class. It's gonna have to wait till we're done. I wanted to explain to you guys this new thing is you can see like those little semi-transparent buttons on the right-hand side of the screen. And if you're on my Discord, you can actually modify those through Discord. So let's try working with those. I put here on Discord a little screenshot of what the bot can now do to modify those little buttons. So in addition to the polls that I sometimes make to make sure that you guys have understood correctly, we now have a way that you can vote so I can see how you're doing, even when I'm like on the whiteboard or busy explaining something. So you no longer have to wait for me to ask you if you're okay. You can let me know at any time by using these vote options. So basically, we're going to be sending messages to the bot on Discord. If you want to vote green, green means that you understand everything fine, you're fine, it's okay, I can keep going. You can type something like green, okay, verde, bien. If you want me to slow down, it's going to be the yellow button. So you'll type stuff like yellow, amarillo, I put conf and slow there as well as options. If you want to ask a question, like you're typing a question in the Twitch chat or Discord and you want me to go look at it, type something like question red, rojo, duda. What else did I put there? I put so many options. Pregunta. And if you have to like go AFK, you have to go get your taquitos, mom's talking to you, whatever, you can vote the gray one. Gris, gray spelled in two different ways, AFK. And if there's a technical problem, if there's something wrong with my stream, something wrong with my microphone, if the camera is showing the wrong thing, then we're going to use the black one, black, negro, problem, tech, whatever. And if you want to clear your vote, like you selected one, but it's not valid anymore, you can clear with something like clear, blue, borra, reset, azul. So those are the options that we can use. And since you already sent your student number to the bot and you have already registered, this should work straight away. So let's all try to vote green. You can either write it here on Discord as such, exclamation vote green, and the bot's going to respond to you. If you don't want to spam the channel, if you would rather want to send it privately, you can also right-click the math bot to message it, and you can vote there. And you can see on the stream numbers appearing when you're voting. So please, 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 everybody vote something now so I can tell that you guys understood how this is working. I know I have like 20 people here, so please let's get like 20 numbers going on the buttons there. You can keep going them, switching them back and forth. Mauricio Vargas, the bot doesn't know what your student ID is, so you have to set that first. It's just like for the MVPs. So whenever I'm explaining and you're understanding well, you're going to put the green thing. Oh, my buttons are too small. Let's make my buttons larger. I wasn't expecting them to get that wide. Let me go change them to make wider buttons so that the text actually fits when there's plenty of you. It's actually not here. It's the join CSS. So we're going to make wider buttons. We're going to make them 300. I could just search or replace here as well. 300, 300. Making bigger buttons for my many students. I hope it still kind of fits on mobile. I don't think OBS is actually going to reload the CSS unless I put it back and forth, maybe. Well, it's going to reload at some point. But the main point here is it's working. I know if you know. So remember, I can see this at any time, just the same way you can see it on the stream. So if I go too quickly, vote yellow. If you have a question and you need me to go look at the question, I don't care if it's in Twist chat or Discord chat, just vote red. If you have to step away, the gray will let me know that you're presently away. And the black one will let me know if there's any kind of trouble. If you are not on my Discord, you could also do this on the web. I'll show you guys how to do it. I also made a little video tutorial, but we're not going to watch it now since you guys can use Discord. So if you go to my website and click Interact in Class, it gives you those same buttons here. And this is the video I was mentioning. So you could just put your email and join and start voting. But when you're on Discord, it's easier to just use Discord to vote. But this is the same exact thing. So if you want to switch between the web and the Discord versions, just put the same email you registered for the tasks. And when you change it here, it's going to change on the stream. And now I'm the one who voted red. So since it's my same email, I could go here to Discord and vote yellow instead. And that red should change into a yellow since it's the same person. So I'm hoping this will be helpful. And we're going to start off with me explaining stuff on the whiteboard conceptually. And then when we understand the new concepts, we're going to come back to the computer to look at the homework assignments. And then we're going to go back to the whiteboard to actually solve the homework assignments. So let's start with that. We are a little tilted. Let's figure out why we're tilted. Slightly. No. Maybe. Come on. Well, that's kind of okay. Okay, so we're going to start talking about graph theory. Graph theory is like my favorite thing on the planet. These are models for networked systems. So we're going to have entities. These could be, for example, be users on Twitter, let's say. Oh, let's use Facebook. These are users on Facebook. And Facebook presently isn't down. So now if a user on Facebook is a friend of another user on Facebook, then they are connected on Facebook. If you're not connected to someone, we don't add the connection. These things, the balls, we call those vertices or nodes or entities or objects or whatever. They're representing the people. Whereas these lines, the connections, we call those edges. So each edge has two endpoints. It goes from one vertex to another vertex. And when you are connected, like when you're friends on Facebook, it means that this vertex is a neighbor of this other vertex. You could have several neighbors. So now this guy here has three neighbors, this one, and this one. And the number of neighbors you have, that's called your degree. So this one has a degree of 3 because he has 3 neighbors. This one has degree 2, this one has degree 1, this one has a 1, this one has a 2, and this one has a 1. We are in green, so I think we're fine thus far. So now, the order of the graph, we denote that by n. It's going to be the cardinality of the vertex set. how many nodes do we have? So how many do I have? I have 1, 2, 3, 4, 5, 6. The order of my graph is 6. The size of my graph, we're going to denote that by m, and it's going to be the cardinality of the edge set. How many edges do I have? 1, 2, 3, 4, 5. I have 5 edges. Okay? So we just have to remember, order means nodes, size means connections. Now, we're going to make our first real calculation today. We're going to calculate the density of a graph. The density means how full of edges is the graph. Because like, for example, now 1 and 3 aren't connected, but they could be. 1 is also not connected to 4, 5, and 6, but it could be. 2 isn't connected to 5. 2 isn't connected to 6. So there are potential edges missing. Our graph would have density 1 if it were full, if it were a complete graph, meaning that absolutely everybody is neighbor of absolutely everybody. And our graph would have a density 0 if I had no edges at all. Nobody has any friends, nobody's connected to anybody. So our density is going to be the fraction of the edges we have present, which is the m here, to the number of edges we could maximally put into the graph. So now, what's the maximum possible size for this graph? For the graph to be complete, all of the n vertices would have to be connected to all of the other vertices. Those would be all the possible pairs we can make. And this is something we learned in the first half of the course. We know that if I have n vertices and I want to make pairs of it, that's going to be the binomial coefficient of n over 2. Because out of the n vertices, I want to make pairs. So what's this going to be? Up, we're going to have the factorial of n. But then since we have the factorial of n minus 2 on the bottom side, it cancels out a ton of things. So I'm going to end up, after the cancellations, just with n multiplying n minus 1 divided by 2. So now, if my density is going to be m divided by this m maximum, what does it look like? I have an m and I'm going to divide it by n multiplying n minus 1, and that's divided by 2. And we should have learned at some point, hopefully high school, possibly later, that when I have a thing divided by a fraction, this thing, I'm actually going to move it up here. So what I'm going to have is 2 times m divided by n multiplying n minus 1. So that's going to be my formula for calculating the density of a graph. Let's take a little picture. And when you know all the stuff that we did in the previous part of the semester, all of this is really easy because you already know what the binomial coefficient is. If you were slacking earlier and you have literally no idea, what does it mean when I put an n over a 2 in parentheses? It just means that you really need to go over the first half of the course because I am not going to be able to explain things to you when you don't really know the stuff we've been studying. This is why we've been studying stuff like this, so that we could talk about stuff like how many edges can I put in a graph, because I know that the edges are pairs and I want to find all the possible pairs. Okay, so we're pretty well set to start working on the exercise, but we still need a couple of more concepts. So remember, we had the size. We had the size of the complete version, which is all the pairs. We have the density. That's the fraction of edges present from edges possible. And we have the degree, which is how many neighbors does everybody have. And a couple of more things we need, then we can actually do homework. When I start from a vertex and I follow edges to get to another vertex, what I'm doing here is that I'm making a path. So for example, 1 to 2 to 4, that's a path because I go from 1 to 2 and then I go to 4. Whereas, for example, 1 to 5, that would not be a path because I cannot go from 2 to 5. So a path is a sequence of vertex visits or a sequence of the edges that represents the same thing that actually goes from one neighbor to another, progressing in the graph. The length of a path is going to be the number of edges we traverse. So the length of the path from 1 to 4, that would be 2, because I need to hop 2 times to get to 4. The length of path from 3 to 6 would be 1, 2, 3, 4. Okay. This graph that we have here, it's a very particular one because there's only one single way to go from every vertex to another vertex. There's only one way to go from 1 to 4. You can only get there through 2. You can't go there any other way. So this is a very easy graph to work with. Graphs in general have tons more edges. Let's put more edges here to make this a little bit harder. So I'll add one here, I'll add one here, I'll add one here, then I'll add one here, and I'll add one here. So now I have tons of paths. I have many ways to go about. Because if I want to go from 1 to 6, I could go through 3 and then to 6. Or I could go to 2 and then to 6. Or I could go from 1 to 2, then to 4, then to 5, and then to 6. So I have multiple different paths for one single way of going from a vertex to another. So the length of the shortest path is called the distance. The distance between 1 and 6 is 2, because the shortest paths that are the 1, 3, 6 and 1, 2, 6, they have length of 2. Even if there are other paths, like there's the 3 path here, 1, 3, 5, 6, or the length 4, 1, 2, 4, 5, 6, those are valid paths, but they don't define the distance, because the distance is the length of the shortest path. Length, I can't write, length of the shortest path. And this is very important to remember. It's the shortest one, not just any, not the longest, not an average. It's the shortest. So if I'm asking you what's the distance to go from one vertex to another, you need to calculate to me what's the shortest way to go. You got to take a picture of this too, so we don't forget. Everybody's still in green. Distance, length of the shortest path. Okay, so now, suppose I know the distances from all the vertices to all the other vertices. We're going to do this with the homework graph in a little while. I can define another concept that's very interesting, the diameter of the graph. So the diameter of the graph is going to be the maximal distance in it. So you would have to calculate for all pairs the distance, and then you need to look at what's the longest distance. So what's the highest number of steps that I will need to be prepared to take to be able to get from anywhere to anywhere else. So in here, it kind of looks like I can go anywhere in 2 steps. Let's try. From 1 to 1, I don't need to go anywhere. That's okay. 1 to 2, I just need 1 step. 1 to 3, 1 step. 1 to 4, 2 steps. 1 to 5, 2 steps. 1 to 6, 2 steps. 2 to itself, 0 steps. 2 to 3, 1. 2 to 4, 1. 2 to 5, 2. 2 to 6, 1. Fine thus far. From 3 to itself, 0 steps. 3 to 4, 1. 3 to 5 is 1. 3 to 6 is also 1. Okay. From 4 to itself, no distance. From 4 to 5, 1. 4 to 6, 2. 5 to itself, no distance. 5 to 6, 1. 6 to itself 0. So the diameter in this case is 2, because that's the longest possible trip we would need to make to get from one point to another. And that's the distance, for example, between 1 and 5. I cannot go from 1 to 5 in less than 2 steps. So when we're calculating the distances, we need to remember to be looking at the shortest path of the vertex pair that we're interested in. Whereas when we're calculating the diameter of the graph, I first need to take all the distances into account, and then I need to pick the largest one of the distances to be able to calculate the diameter. One final concept, and then we can do homework. The same way, I can take a set and then I can make a subset of the set by selecting some of the elements. I could make a subgraph of this graph, selecting some of the vertices. So let's say I want to make a subgraph of all the odd vertices, 1, 3, and 5. If I want to make this subgraph, it means that everybody else is excluded from it. So the subgraph 1, 3, 5, it will only contain the vertices 1, 3, 5, and the only edges I may include are the ones that go between them. So since 5 isn't connected to 1, I only have 2 candidate edges, 1 to 3 and 3 to 5. If I want to take the induced subgraph, it means I have to take all of the possible edges. So the induced subgraph of 1, 3, 5 would be this edge here and then this edge here. But also I can make smaller subgraphs. I could not take this one, but take this one. Or I could not take this one and take this one. Or I could take the subgraph of 1, 2, and 1, 3, 5 and none of their connections. I could get a subgraph that has size 0 and it would still be a subgraph. The important thing in a subgraph is that you can never add edges that were not present in the original, and you can never add vertices that weren't present in the original. But once you've taken the vertices corresponding to your subgraph, you are free to include or not the remaining ones. Unless it's an induced subgraph. In the induced subgraph, you have to take them all. So let's turn this picture into the subgraph induced by those vertices that are prime. So we're going to be getting rid of 4 and 6 because 4 and 6 are not prime. I'm taking another picture. Everybody's still green. So if I take away vertex 4 and I take away vertex 6, it means that the edges that were going to them can no longer exist because they're orphans now. So I have to get rid of this edge here, have to get rid of this edge here, this one here, this one here, this one here, and this one here. And now this is the subgraph induced by those vertices that corresponded to prime numbers. So now what's the order of the new graph? This order is 4 instead of the previous 6. And what's its size? This one has a size of 4 because it has 4 edges in it. Take a picture and write a label for it. So this is the subgraph. I hate typing math because Discord doesn't autocorrect anything. It's trying to make sun graph. Subgraph induced by prime vertices. Okay. So now we're going to go to the computer. We're going to have everybody's going to have a different graph, slightly different one. And we're going to answer questions like these to get points for the third homework. Let's get a website. Let's go here to when we're returning to classes on October 7th. Oh, that's true. We have a second. Let me update it. I don't think I've updated the link. Let me update the link, which means we actually have to go to Google Drive. Da, 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 da. Undergrads, this is August, December. Midterm questionnaire. Shortening the URL, copying the URL. I'll give you guys the URL straight up, and then I'll make sure that I have the correct one on the website. There we go. I can never type my password early in the morning. And we're changing the redirect, so it goes to the same place. Okay, so we have the questionnaire. We are on Twitch. We'll take a moment after we're done with this third homework to discuss any questions you had wrong in the midterm exam. In case you don't know why they were wrong, it would be really nice to talk about it and go over that. Also remember, if you did poorly in the midterm, it doesn't matter. It's only a 20-point exam. You can still pass the class just fine. And we are going to the homework. Assignment 3. I'm going to take a little screenshot for you guys. And it's really important everybody remembers that the assignment is slightly different for every person. So your graph is not going to be exactly the same thing as my graph. And what are the differences? You can notice here that you have this one edge that goes from U to V. Everybody's going to have a different U and V. The rest of the graph is going to be the same. So for me, U is going to be 8 and V is going to be 2. And now remember, E is a set. So if you end up having an edge repeated, the repetition doesn't matter. If your U is 3 and your V is 6, you're not adding anything because your UV already exists. And since these edges are undirected, the edge from 3 to 6 is the same thing as the edge from 6 to 3. So if you had U equal to 6 and V equal to 3, you still wouldn't have to add anything. So the first thing we're all going to do, you guys and me, we're going to draw our own graph. We're first going to draw the edges that we all have, and then we're going to add the edge that everybody has, different, to be able to work with this information. Okay, so I am going back to the whiteboard. You guys are grabbing a notebook. Let's everybody clear our votes now. I'm actually going to clear them for you. And when you have drawn the graph, not including the UV, you vote green again. I want to know that we're all ready to continue. I'm going to draw mine. You're going to try to draw yours, and then we'll compare. The positions of the balls don't matter. What matters is which one is connected to which one. So we're just going to make the shared part first. I first have an edge that goes from 1 to 2. So we all have that. Then we have 1 also connecting to 3. Then we have 2 that's going to connect with a 4. Let's put that one here. Then we have the one that we're postponing. Then 3 is going to connect with a 5. Then 3 is going to connect with a 6, but also 6 connects with a 4. So it's going to be a little bit nicer to move the 4 over here. so that when 3 connects to 6, it's going to be easy to also make 4 connect to 6. Then I have, what do I have next? I have 4 to a 7. 4 goes to a 7. 5 goes to an 8. Then I have 6 to 9 and 7 to 9. So everybody has these edges. All of us have these ones. Then everybody has potentially a different edge to add. Mine goes from 8 to 2. So my edge is going to be kind of long. Let's move these guys a little bit. Let's put the 5 here and the 8 here instead of there, so that when I connect my 2 and my 8, it won't be such a cluster. I'm also going to move my 1 a tiny bit, like this. Okay, so now remember, this is my special edge. You might have a special edge as well, or if your UV was a repetition of an existing edge, then you don't have a special edge, you only have the black ones. But let's vote green once we have been able to make a drawing of our own graph. I'll take a picture of mine in case your Twitch is struggling to get a proper resolution. If you don't want to draw your graph, just vote gray. So I'm going to know not to wait for you. A couple of people have their drawings. When a dozen people have their drawing, we can start answering the questions. And yes, in the final exam, this is the very first thing you're going to be doing. About half of the exam questions are going to be answered based on a drawing of a graph you do first thing in the exam. And as you know, you can go practice the final exam in the same exam system whenever you want. So if you want to know if something's going to be in the exam, just go do the exam. You're going to notice if it's there. Okay, tons of people have their drawing. And it doesn't matter if yours is like mirrored from mine or some of the edges are crossing, if the nodes are in different positions. The important thing is that we have the same connections. It doesn't matter how they're placed. Okay, so now we're actually okay to start talking about the homework questions. The very first one is, what's the maximum degree? So remember, degree is how many neighbors you have. So we're just going to calculate for every vertex, how many neighbors does it have? 8 has 2. This one has 2. This one has 3. This one has 3. There's 2 here, 2 here, 3 here, 3 here, and 2 here. And remember, you might get different numbers from me because you might have a different special edge. So what's the maximum degree? The maximum degree is what's the largest green number that I just wrote. I have a bunch of 2's and a bunch of 3's. So my maximum degree is going to be 3 because that's the highest degree present in my graph. Calculate your maximum degree, write it into the homework system, and grade. If you get it wrong, please take a picture of your graph, post it on the channel so we can try to figure out what's wrong. But it's very important that you show us what's your special edge, because everybody has a different one. So we need to know what your edge UV is. I'm going to clear the votes again. Vote green when you have correctly answered the first question. And remember, if you get tired of spamming the channel, you could just DM the bots your votes, especially if you need more time and you want to vote yellow and you want your buddies not to be able to look at it. Well, just DM it to the bot and you're going to get yellow so we know to wait for you. But I think everybody is okay with this. So now we're going to do fractions. We're going to count our density. Now remember, the order is how many vertices I have. We all have the same vertices. Everybody's order is going to be 9. The size, it's going to depend. If your special edge was an addition, like mine, your size is going to be larger. If it was a repetition, then your size is going to be smaller. How many edges do I have? I'm just going to calculate it by counting on the list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11. You might have 10. I'm going to write here possibly 10. Okay. So the formula for density that we had, it was m multiplied by 2 divided by n multiplying n minus 1. So with my value, I have 2 times 11 multiplied by 9 times 8. We can make some simplifications here. I can get rid of the 2. I can make this into a 4. So I end up having an 11 divided by a 36. If I had had the 10, I would have a 2 times a 10 divided by the 9 times an 8. So I could get a 2 out of here to make this into a 4. Then I could get another 2 out of here to make this into a 5. So I would end up having a 5 divided by 18. And we need to put this in the system as a fraction. So we can use Python, tiny bit. I'm going to type both of them to Python and take a screenshot for you guys. I'm leaving you guys looking at the whiteboard, so it's going to be a little bit easier to know what's going on. And I will also send you a picture of the board. I'm resetting the votes again. When you have correctly graded your density, just vote green again. Ulysses, just write some of them, like a bunch of them. If you round it too early, when my computer compares your results to the correct result, it's going to complain about it. We could actually go modify the code a tiny bit to make it accept roundings. I'll show you guys, because I think it's high time you know how your work's graded. let's go look at how your homework is graded. We're going back to the web server. We're going to where the scripts live. We can't remember which one it is. We're going to look here. Getting better at my password. So now if we want to calculate the density, where's the density? This is homework 3, question 2. Well, there's a tolerance. It's a second decimal tolerance. It takes what you wrote, and then it's going to it's taking the edges in both orders. I think it's taking the edges in both of the orders. Yeah, it's actually slightly confused about what it's doing. It's adding the edge as the smaller of the two to the larger of the two. Oh yeah, it's because I'm not using the formula. I'm using the raw formula. I'm using the order divided by the binomial coefficient. No, the size divided by the binomial coefficient of the order over 2. So it lets you have a problem in the second decimal. But if you try to round it up very high, it's not going to give you the points. But I think everybody is managing to write enough decimals, and we're not struggling with this. So we could go towards the next question, which is the distance between the vertex 1 and the vertex V. My V is 2. Your V might be something else. So let's go to the whiteboard, and I'm going to look at the distance between 1 and V for all possible values of V in my graph. But remember, my graph isn't the same thing as your graph. So your distances might be a little bit different than my distances because you might have a different special edge. So I'm going to actually start making a thing called the distance matrix. So let's make a distance matrix here. I'm going to put all the vertices, 1, 2, 3, 4, 5, 6, 7, 8, 9, as rows, and then again as columns. And I'm going to calculate all the distances. 1 from itself, that's a 0. So if your V is equal to 1, the distance is going to be 0. My V is the 2. So distance from 1 to 2, that's a 1. So that's why I have a 1 as my answer, because I only have one step to go to get from 1 to my V, because my V is a 2. And the distances here, they're symmetrical. Distance from 1 to 2 is the same as the distance from 2 to 1. So 2 to 1 is also 1. Distance from 1 to 3, that's also a 1. 1 to 4, where's 4? It's down here. The distance is 2. There are also many larger paths. There's this 1, 2, 3, 4, 5. But remember, distance is the length of the shortest path. So 1 to 4, that's a 2. 1 to 5, that's also a 2. 1 to 6, that's a 2. 1 to 7, that's a little harder. 1, 2, 3, 1, 2, 3, 4. 3 is the smallest. 1 to 8, that's a 2 for me. Might be a different number for you because I'm using my special edge now. And 1 to 9, 3 seems to be the shortest. So now we should know what's the distance between 1 and V. I'm resetting the votes. When you've been able to grade yours and you know the distance between your V and 1, you vote green again. taking a picture of what I've done thus far. If you're getting tired of typing the vote green stuff, you can just open the website. You can log in with your email, and you can press the buttons there. I can't remember if I made the bot link it. No, I didn't. I should make the bot link it. 1 second. Restarting the bot. There we go. So if you're tired of typing, if you'd rather click, you can just open the website, maybe on your phone or something. And then you can just click the buttons after you put your email. We should make a mobile CSS with buttons that are a little bit smaller. I'll do that between classes. Okay, so now we have the distance. Someone needs a little bit more time. Please send a picture of what we're doing if you need any help. We're going to calculate the diameter. So remember, the diameter is the maximum distance in the entire graph. So the easiest way to do this is to calculate all the distances. So I'm just going to keep filling my distance matrix. And then we're going to look at what's the biggest number. Now it looks like it might be 3, but we got to be sure. So I'm going to add the distances from 2 to everybody else. 2 to itself is a 0. 2 to 3, that's a 2. 2 to 4, that's a 1. 2 to 5, that's a 2 for me, might be different for you. 2 to 6, I have a 2. 2 to 7, that's also 2. 2 to 8, that's different for me because I have the special edge, it's only 1 step away. And 2 to 9, 1, 2, 3 is the shortest. Then 3 to itself is going to be a 0. 3 to 4, that's a 2. 3 to 5, that everybody's going to have a 1 there. 3 to 6, everybody's going to have a 1. 3 to 7, that's going to be a 3. Might be different for you if you had a different special edge. 3 to 8, I have a 2. 3 to 9, I have a 2. And yes, this is something you're probably going to be doing in the exam as well. 4 to itself is a 0. 4 to 5, that looks like a 3. 4 to 6, that's a 1. 4 to 7, that's a 1. 4 to 8, I have 2 because I have the special edge. And 4 to 9, that's also a 2. And now this is very laborious. It's taking a lot of time and it's only 9 vertices. So I'm going to show you guys in a little while how to do this in Python because we can automate all of this. And it's going to be pretty easy to answer these kinds of questions in Python, even if your graph is very large. 5 to itself is a 0. 5 to 6, that's a 2. 5 to 7, 1, 2, 3, 4, 1, 2. We found another contender for diameter. 5 to 7 in my graph, it looks like you cannot do it in less than 4 steps. 5 to 8, that's just 1. 5 to 9, that seems to be a 3. 6 to itself is a 0. 6 to 7 is a 2. 6 to 8 seems to be a 3 for me. And 6 to 9 is a 1. 7 to itself is a 0. 7 to 8, I have a 3. You might have something else. 7 to 9 is direct. 8 to itself is a 0. 8 to 9, 1, 2, 3, 4, 1, 2, 3, 4 seems to be the shortest. And 9 to itself is going to be a 0. So now this thing we have made, this is the distance matrix, and the largest value present in it is 4. So in the diameter box, you should be writing 4 with this data. And if you have a different graph, you have a different diameter. I'm resetting the votes. I know this is going to take more time. I'm going to take a picture. And you guys are going to, for a little while, calculate your distance matrix so that we get the correct response. When we're good with this part, we're going to answer the last question, and then we're going to look at how to do this in Python. You can just put a yellow if you're working on it. You can put a gray if you're not going to work on it, so that we know how this is going. You could also just try to look at the graph, but it's really easy to make a mistake when you're just looking at the graph. It's very easy to overlook one simple thing. One person is still working on it. There is absolutely no rush. Okay, looks like we're pretty okay. Everybody's okay. So lovely. We can start thinking about the very last question in the homework. The very last question is about induced subgraphs. Like I was mentioning before, I could induce a subgraph by selecting a subset of vertices. So now the subset we're going to be selecting, we're using a notation that we learned in the first half of the course. We are getting the difference between the actual vertex set we had, which is our V, and we're taking away the set consisting in U and V. So you need to look at where's your special edge, and you're going to erase or scratch out the endings of your special edge. And now remember, when you take away vertices and you get these edges that aren't connected to anything, you need to take them away as well. Now what remains, this is the induced subgraph because it has all of the permitted vertices and it has all the edges that we had connecting those permitted vertices. So I'm going to take a picture of this, and then we're going to actually answer the question based on the picture. So what's the question? The question is, what is the size of the induced subgraph? Remember that the size is how many edges do I have. So I need to count my edges. I have 1, 2, 3, 4, 5, 6, 7 edges. So I need to go to my homework and I need to type the answer that my induced subgraph has 7 edges. I'm resetting the votes and waiting for you guys to answer yours. Okay, let's see how this is going. Several people have 10 points on the third homework. That's very nice. Percentage is still pretty low. Only 38% of the group is working on this. And this is usually a very kind of like a sad common thing that a lot of people never come back from midterms. I've never really understood it. Why don't they come back from midterms? Because this isn't a particularly hard course and you can still get 80 or more even if you didn't present midterm. So it's a mystery why people don't come back. But I'm glad you guys did. So let's go see how to do this in Python. So we're going to do this the usual FIMA way. We're just going to go up from the homework to find where's the stuff that I'm supposed to have learned. So this is where is all the stuff that I was explaining and some other concepts that we haven't talked about that it would be good that you would read. Like, for example, the edges, they could have directions. We say that two edges are adjacent if they share a vertex, and two vertices are adjacent if they are neighbors. Here's the part about the degree. There's a discussion of when a graph is regular. It has to do with the degree. This is the maximum edges stuff. This is the density. This is the part about the paths and the length of the paths that give you the distance and then the diameter. Then there's questions about when is a graph connected? What are connected components? What's a clique? What's an induced subgraph? What's a spanning tree? This is all stuff that we're going to be needing in the final exam. But as you already know, we're going to be practicing it together. So there's a couple of Python codes here that we can use. I'm going to link them to you straight up in Discord. So we have one that defines a graph. It gives us a class of, hey, I want to make a graph. It's going to have a set of vertices and a set of edges, and I want to know who's a neighbor of whom. So when I add a new vertex, I introduce the vertex, and then I make sure that there's a place to put its neighbors. When I want to connect a vertex with another one, I add the first vertex, and then I add the second one, and then I make the edge to connect them, and I make them each other's neighbors. And then there's also a routine to be able to check the complement of the graph, but we don't actually need that for our homework today because there was absolutely no mention of complements anywhere. So I am going to open my Python. I am going to go to the raw version of this, and I'm going to take the part I actually need. So I'm going to skip the complement part, going to take this, and I'm going to notice that copy pasting this kind of code is absolutely horrible. I have to copy paste it very carefully. Let's see if I can do it. If you miss out on anything, it's going to complain. Let's try again. Okay, now I actually did it right. I was able to copy paste this, and now I could make a graph. So I want to make a graph that corresponds to the homework. So let's actually reopen the homework. It's here somewhere. Okay. So these are the edges that I need to add. So let's define stuff that we need to do this. We need U to be 8 and V to be 2. Then we are going to want to add all of these pairs. Let's see if copy pasting will work. It doesn't want to copy paste, probably because it's formatted. So it's going to be 1 with 2, 1 with 3, 2 with 4, and it's going to be with U with V. I'm going to copy paste this for you guys on Discord so you can take it from there. 3 and 5, 3 and 6, 4 and 6. Then there's going to be, I did something horrible. I hate it when it wraps. Let's make this wide and short. 4 and 6, then 4 and 7. Then I have 5 and 8. Then after 5 and 8, I have 6 and 9. Come on. And then I have a 7 and a 9. I'm so bad at typing. Let's see if I have them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That looks fine. So this I'm copying to you guys on Discord. Oh, it actually looks like I'm copying the whole thing first. So there goes the graph stuff. Now I lost my thing. Let's copy the thing. So now I need to use the routine to connect into a graph these edges. So I'm going to make a mio. It will be a grafo. And then for, let's call them XY in conectar, I want to do mio conecta of X and Y. So now if I look at what Mio looks like, Mio is a graph. Mio's V contains my vertices, and Mio's E contains my edges. It contains them both ways, 7 to 9, 9 to 7, and it puts a unit weight, unit cost on each. I will also show you guys how to do this part. maybe better with 4 spaces. Fuck. There we go. So now I actually have the graph represented in Python. And if I want to answer these questions about my graph, there's actually also this code that explains how to use it. That's the second one that's linked on the page. But we're kind of recreating it now so we don't have to be looking at it. We have to start answering these questions. So how would I find the maximum degree of this graph? Now, remember, we have here mio vecinos. So we can see for each vertex how many neighbors does it have. And the degree would be the number of neighbors it has. So we could just do a for about this. For vertex in mio v, print the length of mio vecinos of that vertex. So these are now the degrees. And if I want to know the maximum degree, I could simply do the maximum of an array that contains the length of mio vecinos of v for, let's not use v, let's use w because v means something else for us now. For w in mio v. So that would be an array. I would close it to take the maximum. So this way I'm able to know what's the maximum degree. I'm going to copy it for you. Of course, calculating the maximum degree, it was really easy because the graph is kind of small. But if you had like 10,000 vertices, you can't draw it. You would have to load it onto a computer and have the computer calculate this for you. Remember to put yellow if you need more time. I'm actually going to go get more water. You guys will get like a minute more time. Then we're going to answer question 2 using Python. It's actually kind of cool. I can take you guys with me. We're in the laundry room now. We're going to get wireless headphones. They're both a blessing and a curse. They're a blessing because you can do all kinds of stuff, and they're a curse when you forget them on when you go to the bathroom. Okay, question 2. I'm going to reset the votes again. If you're struggling, please vote yellow. If you're fine with what we've done thus far, please vote green. It's very helpful for me to know how this is going. And remember, it's not absolutely mandatory that you know how to do this now, but you're going to be a much better engineer if you figure out how to do this sooner than later. So next thing we wanted to calculate was the density. The order of the graph was how many vertices do I have? So mio v. I wrote mio twice. So that's my order. Then remember that when we look at the edges, all the edges are double because they're listed twice here. So my size is actually going to be how many edges have I listed, but I have to divide it by 2 because I've stored them both ways. It's easier to make some calculations like lengths of paths when I store them both ways. But it's very important to remember if you're storing them both ways, don't overcalculate them. So let's take these. So that's my order. So now if I want the density, I can calculate the density as twice the size divided by the order, multiplying the order minus 1. It's very important we put some parentheses so that the stuff happens in a reasonable order. If you get very wrong values for your density, it's probably because you messed up the parentheses somehow. And now for the distance and the diameter, we're actually going to use an algorithm. It's called the Floyd-Warshall algorithm. It's going to visit all the possible orderings of vertices by triples. Like, how do I get from place A to place B, going through place C, if place C takes all the possible values? So we're going to be using the Floyd-Warshall algorithm. We're going to go look at the raw code of it. And it's been written to be compatible with the graph representation that we are using now. I'm going to put it here as well. And I'm going to very carefully copy paste it here to my Python. If your Python is being nasty about copy pasting, just put everything in a file in your idle and press F5 to run. It's much easier than struggling with copy paste. So now I have a Floyd-Warshall algorithm here. So then I could make a distance representation, all the distances, let's just call it distances, by calling Floyd-Warshall algorithm to my graph that's called meal. And then I can look at what do they look like. So what it did is that it calculated for all the pairs the distances. Put this on Discord. I typed the one that doesn't go there. So these are all of my distances, every single one of them. So now if I still have my U and my V, and I want to know the distance from 1 to V, I can just ask it. Hey, dude, how many steps away is 1 from V? So like, how many steps away would 2 be from 9? How many steps away would be 8 from 7? How many steps away would be 8 from 9? How many steps away would be 2 from 6? This thing knows everything. And it calculated those also both ways, so it doesn't matter in which order you're asking it. So all the distances are now there. And now if I want the diameter, this is also very easy because the diameter is the biggest distance. So how do I get the values of the distances? I could just ask distances values, and it's only going to show me the value instead of showing me from where to where does it go. So the maximum of these values, that's going to be our diameter. And I can't spell again. Diameter is the maximum of the values of the distances. To answer the very last question in Python, it's easier to think in terms of the forbidden vertices. So our forbidden vertices are going to be our U and our V. So in my case, those are the 8 and the 2. So now the permitted would be all the vertices except the forbidden ones. So for me, that would be 1, 3, 4, 5, 6, 7, 9. Now, if I want to know how many edges are there in the subgraph induced by these, I could calculate them, present equals 0. So then I could just iterate over the edges for x, y in mio e. If x is in permitted and y is also in permitted, then it means I am going to take this edge into account. Because now I'm visiting every single one of the edges and I'm checking if both endpoints are in the permitted set, then it still counts. And now remember, I'm going to get double. It's going to be 14 instead of 7 because all of my edges are double. So at the very end of it, if I simply divide my result by 2, I am going to get the correct answer for the problem. If I want it to be an integer division, I can just do this. No, I've divided by twice now because I'm dumb. But I should have just put in the double thing here. So let's copy this code for you guys as well. What I did here was first I defined the forbidden as the two vertices that I am getting rid of. Then I defined permitted as the other vertices. Then I initialized the counter present to be 0. Then I iterated over all of the edges. I checked if both of the endpoints of the edge are in the permitted set. Then I calculate this as a present edge. And at the very end, I want it to look at what's present, but divided by 2. I'm going to try copying and pasting from Discord. Oh, it doesn't like it when there isn't enters there since I'm copy pasting. Yes. Because why do I need to put these enters here? So that this for and this if, they actually close, so that the print doesn't go in them. When you're copy pasting, it's really important to leave the blank lines. If it were in a file, you wouldn't have to. So let's actually try that. I am going to close this and go to idle in case anybody here is struggling with idle. And I'm going to make a file. I'm going to go here as new file and put everything we just did in this file. So I'm going to scroll all the way up here. We defined this graph. After we defined this graph, we defined what are the edges that we wanted to connect. After that, we connected the edges into a graph. After that, we got the max degree. So that was going to be the answer to our question 1, the max degree. Then we calculated the order. We calculated the size. Then we calculated the density. And that was going to be the answer to our second question. After this, we incorporated the Floyd-Warshall algorithm here. Then we calculated the distances. Then we could consult the distance between 1 and v, and that's going to be the answer to question 3. Let's put spaces here. It's going to be easier to understand. Then we took the diameter. That was going to be the answer to our question 4. After that, we made a set of forbidden vertices to be able to calculate the induced subgraph. And then we get the answer for question 5. Then we will pick F5. It wants to save. Or we could call this T3 because it's the all of the homework 3. And I forgot the part where I connected, where I defined U and V. My U was an 8 and my V was a 2, right? So now I have a program that spits me out the answers to the entire homework. Nice and easy. So let's give you guys that file just to make it very shameful not to have full points in this exercise. Wish I had any idea where these go. Okay, they go to documents. So let's go to documents and get you guys that file. Date modified T3. So now that's easy mode. The literally only thing you need to do is type in your U and your V and run this, and it is going to spit you out the 5 responses to homework 3. So if anyone here doesn't have 10 points in homework 3, that's just laziness because I just gave you the right answers to your homework. Okay, Kirby, it's important to send a DM to the MathBot. You can just right click it to send a message with your student ID. Otherwise, it can't let you vote. So let's make a poll. Okay, tons of people understand it well. And then the second important thing today is whether you understand all of the midterm exam questions. It's okay if you made a little mistake. We all make little mistakes. But if there's a question you simply don't know how to answer, it's important we take time to learn it today because we do need to master all of that information. As you can tell, we're using those things all the time. We're using the difference of sets today. We were using the binomial coefficient today. So if there are things you didn't understand, those things are going to hit you in the face later on. And it's really important we talk about it. Then the third thing I need to know, if you already had time to respond to the questionnaire, that's the midterm questionnaire I linked today, click green. If you haven't responded to that yet, this is the link again. So it's similar than the one we filled in the beginning of the semester, but it's not the same exact thing. There's a couple of questions of how did you do in the midterm? How did you prepare for the midterm? That kind of stuff. It doesn't take you long, but it's very helpful to me. So since we seem to be fine, I am going to stop streaming on Twitch for now. I'll be pending on the Discord channel. If you have any doubts, any questions, any difficulties, you can come to the voice channel if you want to talk to me, or you can just type here in this channel. If you want to look at the same stuff again at noon today, I will stream this stuff again in Spanish for the V1 group. So you're welcome to join us at noon if you want to get a little quick review of what's going on with basic concepts of graphs. Thank you for using the little voting thing. It's much easier for me to know how we're doing when I can just look at the green thingy on the stream. So I'll catch you guys next week to do more cool things. And we're going to be using Python more and more because some things are just going to be too complex to do by hand going forward from here. Also, I remind you that if you had trouble with following with what I was doing on Python, you can either rewatch the Twitch stream or you can watch the video where I'm explaining how to do this homework because I'm going to be using the Floyd-Warshall code there as well. But that's all on Twitch for Discrete Math M4 for today.